And welcome everyone to today's webinar, New Features in RISA-3D, RISAFloor, and RISAFoundation. For those of you that are current RISA users, you'll have noticed that within the last couple of weeks you've received installation information for these 3 new versions. We have a lot of exciting new features, and we thought this would be a good opportunity to kind of go over the individual features for each program. As Debbie mentioned, the new versions are up here on the screen. RISA-3D version 13, RISAFloor version 9, and RISAFoundation version 7. Although today we're going to cover the individual new features for each program, I did want to reiterate how these 3 programs are interoperable, meaning that you can pass information back and forth. So today I'm going to be showing you individual models. We'll do like one in RISAFloor, one in RISA-3D, and one RISAFoundation, but we won't be showing the integration. But in reality, if you were doing a project, you could start your model in RISAFloor, take all of the gravity members and design them in RISAFloor, transfer that model to RISA-3D to design the lateral elements, and then transfer all of the information for both gravity and lateral elements into RISAFoundation to get the foundation design. If you're interested in more information on any of these products, feel free to contact either Debbie or myself. We'd be happy to answer questions about the programs or the integration. So the first program we're going to talk about today is what's new in RISA-3D version 13. We had a lot of exciting new additions. As many of you know, we have some new design codes both in the US and Canada. So we've continued to add. We try to stay up to date on all of those. For our cold form steel codes, we have added the updated AISI 2012 code, as well as the Canadian 2012 code and the Conocero, which is the Mexican 2012 code. And we're going to be working with cold form quite a bit today because we've got some exciting changes with that. We also added Canadian wood design for the CSA 086, the 2009 edition. We've had the US code for quite a few years now, and we're excited to be able to offer our Canadian customers this design code for wood as well. We also added the updated masonry code, the 2013 masonry code. These 3 codes are part of the 2015 IBC, so with our upcoming version 14 release, we will be completely IBC 2015 compatible. As I mentioned, we had some exciting changes for cold form steel. We've added the ability to do a code check for back-to-back cold form steel members, as well as enhancing a lot of the individual properties for those steel members. So I'm just going to take a break here from our PowerPoint presentation and pop on over to RISA-3D, and we'll get started. I want to do a little bit, show you a little bit of the modeling within RISA-3D as well. For some of you guys, this might be new. It's some new tips and tricks, but it's a good way to show us what's new in cold form. So the best way to show you the cold form design is actually to create just a quick truss. So I'm going to use our section sets here to create a couple different section sets for our cold form steel. I'm going to create a cord section set as well as a web section set. The reason I'm creating section sets first is because I have multiple members that are of the same property. So rather than have to redraw them multiple times, I can just keep them all grouped together. When we look at our shape for a cord, we're going to do our back-to-back section. We've always had the ability to do back-to-back and face-to-face sections. So you're probably familiar with this interface here, but now we have the ability to actually do the design check on them. So we're going to be able to look at the design results. So for our model here, we're going to do a 6-inch section, and we're going to do a CS section that is back-to-back. We do have a number of different manufacturers. I'm using SSMA, but you can see there's a number of different custom manufacturers here as well that you can select. For this type of structure for a truss, we're not going to really worry about the member type. I'm just going to keep it as beam. If you were doing a larger structure, like let's say a building, it would be more important to be able to differentiate between a column or a vertical brace or horizontal brace. Our design list, which is what we use to redesign it. So you've assigned it this section over here, this 6-inch section. But if that section fails, you'll be able to go, we'll actually suggest some shapes for you. So I want to be sure that it's also suggesting a back-to-back CS shape so that it's the shape properties that I want. For my web section, I'm going to do a single cross-section property. So I'm still going to stick with a 6-inch section, but I'm going to do a CU basically without the lips there. I'm going to do a CU. Again, I'm going to do a 6-inch section, but it's going to be a single section from the SSMA. And for my redesign list, I also want to choose a single section CU because that's what the original section that I chose. Once you set up your section sets, then you can actually go ahead and draw in your model. I'm gonna cheat a little bit and use our template generator. If you go to the Insert pull-down menu and you go all the way to the bottom, there's an option here called Structure Generate. Some of you guys may use our templates and some of you guys may not. This is a really great way to start a model, whether you're doing, you know, some type of 3D frame, you know, for a building, or in our case, we're going to do a truss. If you're doing more plate models, you can use a geodesic dome, a cylinder, a cone. We have some really great applications for industrial tanks as well. You know, if you have a conical top on top of a cylindrical tank, you can use 2 of these together and put them together. So it's a really nice way to save you some modeling time. In our case, we're going to use a truss, the truss generator. When you open up the truss generator, you have a lot of options as far as the type of truss that you would like to build. You can see the configurations over here on the right. You know, Pratt A, Pratt B, Warren A, Warren B, or just a cross truss. We're going to stick with a Pratt A truss, which is the first truss that's on here. And then that's selected over here. As I mentioned, we're doing cold form because I want to show you those back-to-back cold form checks. So we're going to do a cold form. We already created our section sets, and this is why I did this first, because it makes it really easy. It'll just assign those section sets to your members. So for the top and bottom chords, I want to use that chord section set I created, but for the verticals and diagonals, I want to use the web option there. Now, you can make this, you know, truss anything you want. If you want it to be a rectangular truss, you can. In our case, we're going to do a triangular truss. So I'm not going to have a height in the middle or at the end. I'm going to leave those values blank. I'm also going to make it a triangular truss so that the A and the C values are 0. But I'm gonna make it a 10-foot high truss here at that B value. And then it asks me as far as where you would like it. Do you want it center line to center line or outer distance to outer distance? I'm going to choose center line to center line for our modeling. For the panel length, it's the number of panels you want on each side. So we're going to create for our model 3 panels at 4 feet on each of these sides. Now, you aren't forced to do them at equal increments like that. Let's say I wanted to do them at unequal increments. I could say I want 1 at 4, 1 at 5, and 1 at 6. And then you could say I want 2 at 4. So you can kind of combine the equal increments with specific distances. For our case, we're going to do 3 at 4 on both sides. You do have the ability to say whether you want this bottom chord or the top chord to be continuous, or if you'd like it to be individual segments that are pinned. I do want it to be continuous, so I'm going to go ahead and leave that blank and say I don't want it to be pin. And when I click OK here, it's going to generate this truss for me. So you can see how quickly that was to do it. Yes, I could have drawn it in myself as well, but it makes it really nice to have that generator do some of the work for you. And as I mentioned, I'm just going to go back to that one more time. It's not just trusses. You can do a 3D frame for a building, any kind of arc that you want to do, or any of these plate models as well. So I'd highly encourage you to kind of play around with that section of the program. Once we have our truss built here, we could go ahead and take a look to be sure it did add those sections properly. I'm going to look in an isometric view, and I can see that I have some back-to-back channels on the top. I have the single channels on the bottom. And if you scroll in tight enough, you can even see that these are the CUs versus the CSs with that lip or not having that lip. So I'll go ahead and turn off that 3D rendering and get back to my full screen here. I'd like to add some boundary conditions to this truss. It's just a simple pin-pin truss, but a question we get asked quite a bit in tech support is, you know, I have a pin-pin model, whether it be a beam or a truss or a frame, and I'm getting an instability. And nobody likes that red box that you get when it says, oh, you've got an instability. Do you want to see where we've locked the joints? The thing about RISA-3D is it is a full 3-dimensional program. So you got to think of it as not necessarily when we look at it, we say, hey, this is a stable model because we're going to only load it vertically. But for RISA-3D, this is a 3-dimensional problem. So right now with my current boundary conditions, this truss could just flip and flop out of plane. Now, you and I know as engineers that there's no out-of-plane load, but the program just sees this as a big matrix to solve. And so there's a 0 in the diagonal, it's not going to be able to solve it. So we need to tell the program that, hey, we're going to brace it for anything that's out of plane so it can't flip and flop out. Now we could go ahead and put boundary conditions at any of these nodes to do that, but there's a little trick if you go into the boundary conditions spreadsheet. When you have a 2D frame model, and again, it could be a frame, it could be a truss, anything that's a two-dimensional frame, and you are not looking at out-of-plane loads at all, then you can actually create another boundary condition. And instead of giving it a joint label like joint 1 or joint 2, you just say all, which means all the joints in this model. And then you can go ahead and fix it for out of plane. Now, some of you may or may not know the difference between reaction and fixed in our boundary conditions. It actually, the behavior is the exact same as far as how it restrains the model, in that it's going to keep it as fixed. But when I select fixed, it's not going to report any reactions for me, which I don't want reactions for all of my joints in the Z direction because there's no load there. So that's why I chose fixed. Whereas here, when I say reaction, I actually want it to tell me, is it a 5 kip reaction? It is a 4.6. So that's the difference between those two entries there. So now I've got my stable model. I'm ready to add in some loads. The first thing I want to do is add in some gravity loads. So I'm just going to do a real quick dead load model for this. I am going to give it a category of dead load. The 3 entries here are the self-weight of the model. So I'm going to say, yes, I want it to have its self-weight in the Y direction. And then I want to add in some point loads at the joints here. So I'm going to go ahead real quickly and add in some point loads. I'm just going to say these are about 500 pounds each. And then I can just click on those joints and it adds in those loads. So now I'm ready to run it. I just got to define what my load combination is. We do have a great load combination generator here. You can go ahead and manually enter in any load combinations that you want. Or you, I tend to use the load combination generator a lot more. I think that's more popular with most engineers. You select which code you wanted to generate the loads for, IBC, ASCE. You can choose older codes or current ones. I'm going to choose the 2012 IBC strength. I didn't add any snow load, rain load, or roof live load, so I'm going to uncheck those. You do have the option for wind and seismic. Again, we're not doing any wind and seismic for this simple truss. But you do have the option to add those as well. So for my gravity loads here, I'm going to click generate, and it just generated 2 of them there. So I'll go ahead, and since I only have dead load, I'm just going to solve that first one. And then I'm going to take a look at the results. So we really are interested in the design results for this. Of course, you can look at the joint reactions if you want. You can display any of them. If I want to take a look and I want to say, what is the reaction in the 3 directions, include the magnitude. And it's going to go ahead and plot those for me so I can see the symmetrical results. I always like to plot deflections and reactions. It's just a good way for me to feel comfortable with how the model is behaving. Did I model it the way that I intended it to? So just going to go ahead and take a look at the deflection as well. I'm going to increase this factor maybe to 100 just so I can actually see it. And that looks like a deflection that I would expect. So that gives me a comfort to know that I'm pretty close to the results that I'm looking for. So when you're looking at design results, you have the ability to look at them either in the spreadsheets or using the detail report. So there's a button here called Design Results. That's going to, if you go to the Cold Form tab, it'll go ahead and look in here. So now it's giving me an error message. It says cannot do the code check. Connector spacing A is greater than L over 6. So one of the things about back-to-back channels is you have to be able to specify where it's connecting those 2 channels together. And I did not do that, so I left it blank. So it thinks that these 2 are not connected except at their ends. So I need to go back and make that change. It's always a good idea to take a look at the design results spreadsheet. If I had color-coded these by their design code check, then when I get in here, the unity check, when I get in here and look at it, they're black. And black means no calc. And that means something has gone wrong. So if you see a black member, it's always a good idea to either look at the detail report or the design results, because it's going to tell you exactly what happened. So for those chord members, I want to go back in and I want to tell it how often they're connected together, those back-to-back channels. So I'm going to go in the members spreadsheet. And if you go to the cold form tab, you'll notice it's all split up by material. Over here on the right is a new column called A, which is actually the spacing of those connectors. So I'm going to use one of the spreadsheet tools here. I'm going to highlight just the 4 members that are my chords. I'm going to right click and I'm going to say fill block. Basically what I do is I want to enter in the same value for all 4 of those cells, and I don't want to have to do a 1 enter, 1 enter, 1 enter. So if I just go ahead and say fill block, it will actually put that value in all 4 of those entries. Now, for a small model like this, it wouldn't have taken me much time to enter those in, but for larger models where you have, 50, 100 members that you're trying to change at the same time, this fill block feature can be really handy. So let's go ahead and run that again and take a look, and I can see now that they're all passing. So when I go into the design results spreadsheet, I get unity checks for all of them. All of them are under 1, so I know that I'm going to get good results there. Now, this gives you all the information that you need in the spreadsheet, but I tend to like the detail reports a little bit more. They give a little bit, the information is laid out a little bit more clearly, at least in my opinion, and so it's a lot easier to read. So if you go to a detail report for this top cord member, this is a back-to-back channel, you'll notice down here at the top it gives all the analysis results. At the bottom it gives all the design results. Now some of this is going to be similar to what you've seen before, but you're going to see some new additions. For the back-to-back, you're going to see that spacing that we just added of 1 foot. You're also going to see all these new values on the right that we've added. These are all of your effective section property values. These have been added not only for back-to-back, but also for any of the single sections as well. It's a great way if you're trying to do verification to be able to compare us to handcalcs or other programs to see if where the differences are, and it should match exactly. Also, you'll notice down here we have a C sub W value that has been added. So again, that's another factor that makes it a lot easier if you're trying to do any type of verification to be able to add it. Now, I'm just going to go ahead and show you, those are the 2 top cords. Here's a typical web member, so you'll see those same properties, effective properties over here on the right, which makes it really nice to be able to look at those. Now, if you look at our design results, we're pretty low on the unity check, right? We can go up to 0.99. And our biggest one is at 0.299. So we've probably over-designed these members a little bit. So what I can do is I can go ahead and go into the suggested design. And in the suggested design, it's going to tell you what the current shape is and what the new shape is that it recommends. So you can see I have a 6-inch shape here, 6-inch section, and it's recommending that I have, a 3-inch section. So you do have the ability to change it. And if you want the program to design it, you can go ahead and say, okay, I do want it to redesign. Let's say I wanted to redesign the cord, but not the webs, or the web, but not the cord, or all of them. And then you can go ahead and right click and it says solve again using the suggested shape. So it's going to take those members that we just had and replace them with the suggested. And now you'll notice I'm getting a lot closer. I'm up to 0.757 for my code check. And when I look at my detail report for that member, I can go ahead and go down here and take a closer look at it. So I'm a lot closer at the 0.757 than I was before. So that's kind of a good form. Let's go back and look at some of the other changes that we've made. So in addition to adding code checks, we also added a RISA vector solver. Now this has to do with our dynamic analysis, and this is kind of our first steps towards time history. So we'll be able to, in our next version, you're going to see time history analysis within RISA-3D. So when we talk about RISA Vectors, it's just another solver that we use. I'm going to go back to our RISA-3D so you can see where this is added within the program. The reason that we're doing RISA Vectors is a lot of times for larger models, you're getting a large number of local modes. And they don't necessarily, those local modes don't necessarily add to the lateral response. So a RISA vector is another way to determine the modes. It's load dependent. So it increases the speed and accuracy for your response spectra analysis. And it's going to eliminate a lot of those local modes that aren't really adding to your lateral response anyways. So if you want to run a RISA vector analysis in the global parameters for any of your models that you're doing a dynamic analysis for, on the solution tab, there's an option here called advanced. So if you click on the advanced section on the global parameters, you'll notice that down here in the dynamic, down here in the right corner, the dynamic options, there used to just be a standard or accelerated solver. And now there's something called a RISA vector solver. So again, this is not necessarily something, if you're not doing a dynamic analysis, you never even have to look at this. But for those of you that are doing response spectra analysis, this is a great way to kind of get higher mass participation in a fewer number of modes. Again, for those models where you have, a large number of local modes. So let's go back and see some of our other features that are involved. We also added some additional new features to our moving loads. So it used to be that you could run a moving load at a time, but now you have the ability to run a batch solution with moving loads, which is really handy when you're trying to figure out, is the moving load the governing, or is the, static loads the governing? So you can actually take a look at that as well. You'll notice that I'm going through these new features. One thing that I want to show you guys is for every new release, we have a portion of our website that is dedicated to these new features. And all of the things that I'm showing you in today's webinar are also available in the form of either like a technical blog entry, which is like a one-page tutorial, or maybe a short video on it. So if you go to RISA.com on the front page of our website, you'll notice it says, so what's new? In all of these different programs. And if you click on it, for instance, we were just speaking about RISA-3D. If you click on RISA-3D, it takes you to our new features page. And this is where it lists all of the new features that I just talked about. So you can see them here, and it tells you the material code updates, and then it gives you options for tutorials. Sometimes it's going to be videos, but it's showing you how to use these new features. It's a great way to learn the new features. You can also, this webinar will be recorded, so of course you can listen to this again. But you just click on the program you're interested in, RISAFoundation, RISAFloor, whatever program it is, and it gives you all of these videos and tutorials. So I'd highly encourage you to go check that out on our website as well. Okay, so we're going to go back and take a look at our next program, which is RISAFloor. RISAFloor version 9 has a lot of really great features in it. For those of you that are familiar with RISAFloor, we recently, in fall of last year, added the ability to do elevated concrete slabs. So there's now two versions of RISAFloor. There's RISAFloor, which you guys have always known, that does, hot rolled steel, cold form steel, composite, wood, masonry, cold form. But now you also have the ability, if you want to, do elevated concrete slab design for two-way slabs. And so that component is called RISAFloor ES. And you guys might have noticed it within RISAFloor. When you go to add a new floor, it does tell you just have the option for an elevated concrete slab. So in our fall release, we added that elevated concrete slab. And you had the ability to take it into RISA-3D to do a rigid diaphragm analysis. But in the recent release of version 9, we actually give you the ability to do a semi-rigid diaphragm analysis for slabs. So we're going to go ahead and take a look at a model here. And I'm going to close down RISA-3D. And I'm going to open up RISAFloor. Let me just take a look here. So we're going to open up RISAFloor. I'm going to open up a model that I've already created, and we're going to add some new features to it, just to be able to show you some of the modeling for the two-way slab design. So as I mentioned before, when you open up RISAFloor, I'm just going to go ahead and turn these off. When you open up RISAFloor, if you go to insert a new floor in a model, you'll notice that there's two options now, a concrete floor slab or a beam supported slab. So in previous versions, you just saw the beam supported floor, but now you have that concrete floor slab. If this is grayed out in your program, it just means you're not authorized for the elevated slab. So give us a call. We'd be happy to give you pricing on that. So this is a model that I've already created that's a two-way slab design. I've already defined all of the design strips in the north-south direction, which is the vertical direction on your screen. But I want to show you how you can define them. So we're gonna create some in the east-west direction. So the way that you create design strips within RISAFloor ES is first you create a support line. So you're going to draw a support line. Now, these are completely customizable. So I've actually drawn in all of these support lines up here already. But you'll notice in the top half of my structure, we could probably get 5 engineers in a room and 5 would decide that, 5 different ways to design this. Some people might design it the strip going across and then, cantilevering out over here, or some people might design this strip, cantilevering out. It is completely up to you. You can make any changes you want. I mean, you can, model them any way you want. I'm going to show you that down here at the bottom. So I want to create a support line, and I'm going to create it in the east-west direction. And obviously, I want the east-west rebar, the rebar running in the east-west direction. And I'm going to click apply. And then it literally is just, you know, clicking across at your column lines and the edge of your structure that you can go ahead and do this. Now, like I said, you can make it as funky as you want, right? I could come down here and go all the way and across. It's completely up to you how you want to do these support lines. In some cases, like this section over here, you know, like I said, you might have different opinion on how you should model these support lines. For me, I'm just going to cantilever it out a little bit over here. It does not have to end on a support line. It can end anywhere you want in the middle of your slab. So I'm just going to go ahead and cantilever that out there. Now for the rest of my structure, I'm going to run it as column lines so we can get some column strips and middle strips. But like I said, it's completely customizable, so you can, you know, create whatever, you know, whatever strip directions that you want. Now you'll notice that it is labeling them a little bit differently. So we have support line 25. So this entire strength, or this entire level here, is support line 25. And then you're going to have different spans within that support line. So I have span 1, 2, 3, you know, all of that. That's going to make it easier to take a look at our results to see where things are governing, which span they're governing in. Once you create your support lines, you can have the program automatically generate the design strips. So basically, it's going to take some tributary area and create some design strips. Now, the one thing that I love about, and let me just display those so that you can actually see those design strips. The one thing I love about RISAFloor ES is that, yes, it automatically creates those design strips, but you're going to have areas like up here where you have overlapping design strips, or maybe they're not really what you want. RISAFloor ES gives you the ability to modify those. So if I go back over here, I can say, you know what, I want to, you know, modify the end of my, I want to redraw the edge of my section there. So I just click on it, and then I can take it anywhere I want within there and extend it. So over here, if I don't want this, you know, this to be, you know, way over here, I can move it. I don't want this one to be here. I want it to be up here. I can move it. So you have the ability to go ahead and modify the edge of any of these design strips. And this is a good example over here where I did the cantilever here. I really don't want them overlapping, so I'm just going to click on it. I'm going to say, hey, I want it to go back, you know, as close to that edge as I can. And I could actually go over here and change this one if I wanted so that they don't overlap. I can move this edge over here, back down here. So you have the ability to modify these as much as you want. It really does give you a lot of flexibility for the design. Again, over here, I could go and I could say, okay, I want this to be up here. So you can change it however you would like to, you know, modify them. I really do like the flexibility that this gives you. So once you have the design strips, you know, looking the way that you want, you're ready to run your analysis on this model. So I can go ahead and, I'm just going to save this real quick. I'm going to go ahead and run the analysis. Now what this is doing, this is a full 3D finite element analysis model. So what it's doing is it's taking all of your loads that you've put on your slab, all of these design strip locations, and it's breaking it down and creating a mesh. It's also breaking down all the area loads and distributing them to the individual strips. So once your analysis is done, you'll be able to look at some of the design results for the gravity. As I mentioned before, this is not new as far as everything that I'm adding in here. This design strips and support lines and everything has been there since we released RISAFloor ES in fall of 2014. But the ability to be able to transfer it to RISA-3D for a semi-rigid analysis is new. And so I'm really excited to be able to show you how that goes over and all of the plate meshing that you're able to see within RISA-3D. So I'm going to go ahead over here and take a look at a detail report on one of these strips. So I'm going to do this strip down here that's at the bottom of the structure. So just like you're used to seeing design or detail reports for members, the detail report for elevated slab design is very similar. So this is the design strip. This is design strip 25. You can see that at the top. This is our support line 25. It gives you all of the analysis results. So this is the enveloped shear and bending moment diagram for this particular support line. And then here's the analysis and deflection results for it. Now, again, this is the support line. So you can go ahead and take a look at any of the design strips or the support line. So right now I'm looking at the support line. But you'll notice up here in the lower or in the upper left-hand corner, I can choose a column strip, middle strip, or left strip. So I'm going to go ahead and go over here and I'm going to close this detail report. When I look at it, you'll notice that, I created a strip. This is the strip I'm looking at. I created this strip here. It automatically knows to create, a column strip or a middle strip on the left and a middle strip on the right. So that's what it's looking at right there when I look at that report, is the different areas of that strip. So let's go ahead and take a look at the column strip here. So in addition to the analysis results for the shear and bending moment diagram, it also gives you the design results here. So you can see where the columns are. So it tells you which column, the column label at each location, and what the reinforcement is at each location. Now, this is a good overall view of it, but if you really want any kind of detail, it's best to look at the individual cuts that are governing. So if I go ahead and take a look down here at my design results, and I can see here's my code check results. Here's the top bending results design and the bottom bending results design. And the bottom, we actually give you the deflection ratios as well. So you can see I'm well above the the limits that I need. So let's take a look and see what would be the governing. So for my top bending check, I can see that number 5's at 8 is my governing section. That occurs on support line 25, right? And then we're at span 5, cross section 1. So it's really easy to get to it. If you want to see the details about why this is the governing check here, then I go ahead and I can say, okay, I want to go over to that cut. And I remember that was span 5, right? So I'm going to switch it to span 5, and it was cut 1. Now we do by default, we do 50 cuts per section. So you'll notice if you go back here, some of these are saying, okay, cut 50 was the governing one. For the bottom rebar, it was cut 27 or cut 21. So you can look at any of those individual checks. If you want to increase or decrease the number of cuts, you absolutely can do that. That's part of your defaults that are set up, and you can change that at any time. So I'm going to go ahead and go over here and take a look at that span 5, cut 1. And it says I need number 5's at 8 on the top. If I look at the top required here, it says that the area of steel required is 3.475 to meet that 4/3 ratio. And so I have a top area still provided of 3.682. So that's a pretty close, unity check for what it is. I'm at about 70% capacity. I also have a bottom check here, so you can actually check that at the same time if you want. So I have an area still required of 4.08 inches, and this is, or cubic inches, I'm sorry, square inches. And the bottom of area still provided is 4.7. So you can see that as well. If you want to make a change to any of these, you go in here and say, well, I'm still 30%, I still have 30% capacity here. What if I wanted to change it? What if I didn't want number 5s? What if I wanted to try and see if number 4s work? You absolutely can do that. When you're looking at your slab design rules, you have the option to change those. So we're in the east-west here. So I'm going to go ahead in here and say I want to change these. So you can change the cover, the size of the bar. We do optimize the spacing for you, but if you want to, fix it so you wanted it to be at 8 inches, you could go ahead and go in here and say my minimum and maximum is both at 8, and it will automatically do that for you. So you can change these at any time. You can create as many different, design rules as you want. So within that dialogue that I was talking about, you could create 4 or 5 different design rules. Let's say you have, an east and a west wing for your model. Then you could create different design rules for those different wings. RISAFloor does give you the ability to be able to create different slabs within the same model as well. So let's say you have, a larger complex with 2 slabs that are separate. Maybe they share a lower floor level, but at the top there's 2 different towers, for instance. You absolutely can run those. RISAFloor will see them as 2 separate towers, and they'll behave separately. And when you take a look at the results in RISA-3D, you can even see that they vibrate separately from each other. So once our analysis is done and we've kind of optimized our gravity design for these slabs, we're ready to take it on over to RISA-3D. And it's really easy to do that. You just use this director button over in the upper right-hand corner and send this model on over to RISA-3D. As I mentioned before, for those of you that are not familiar with RISAFloor and RISA-3D, RISAFloor is used to do the gravity design for the building, and RISA-3D is used to do the lateral design. So you'll notice that the first thing it asks when I come over is what is the wind loads that are applied to this structure. So you can modify what the wind code is that you want to do, what the exposure category is, and then the program will automatically generate those forces for you. It does the same thing for seismic design. So you'll notice it does not only does it do the seismic design in each direction, but it also does those 5% eccentric points to give you some of that torsion, the induced torsion that the code requires. So once we get this over into RISAFloor, you'll notice that it does bring over, I tagged everything as lateral, so it brought over all of my columns as well as my walls. You can see the openings in your diaphragm. It also brings over all of the gravity loads. So when you go over, you're not losing the gravity loads. You'll notice that when I scroll through these, it actually will bring over all of those dead and live loads that I applied within RISAFloor as well. So I'm going to go ahead and turn those off so I can see that here. If for our case here, we're going to run a real simple analysis, but if you were doing this, you're going to want to, take a look at your seismic loads, and we can do that as well here, creating your seismic loads that are applied at your different columns. You can definitely do a lot more investigation than we're doing within this short demonstration. So I'm actually just going to create one, we're just going to look at dead load. I want to be able to show you the mesh that comes over that is truly, a finite element analysis. Let me just save that real quick. I'm going to go ahead and run just that single dead load combination. Again, it should give me the same results as I had before because I'm just running dead load just like I did in RISAFloor. So once the analysis is run within here, and you can add additional loads, you can add additional members. That's the flexibility of using RISA-3D and RISAFloor together, is that RISA-3D gives you the ability to add any members that, that didn't really fit within the RISAFloor program. So we can actually show our mesh here. So you can see here on the model that it is a full 3D analysis with the plate elements, and the mesh is, you can see you have a more dense mesh around the columns, and it's a little bit bigger in the middle spans, just as we'd expect. And just like, plate elements within RISA-3D, you have those same ability to view results as you would with RISA-3D plates. So if I want to go ahead and take a look in here, let's say we want to look at maybe our moment, our MZ moment, I can say apply. And you can go ahead and take a look at all the different contours. We're getting a lot more moment around our columns, which we would expect, right, than we do in our midspan. And you can see the legend over here to be able to tell you what those forces are. So that's a good general overview of, the semi-rigid diaphragms going into RISA-3D as well. Some other features that we've added in RISAFloor, we also added the ability to do a DXF export of all of that concrete reinforcement for your slab. So if we go ahead and go back into RISAFloor there, then we can, I'm going to take this model back over into RISAFloor. You just go up to File, you say Export, and you're going to export it as a DXF file. We'll say this is slab. We'll call it a semi-rigid because that's what we're doing. So we'll say that's a semi-rigid. It creates that, and then we can open up AutoCAD. I've already opened this up within AutoCAD to take a look at, but you can actually zoom in here and you'll see that it has 4 number 5s at 18, 3 number 5s at 18. So it gives you all of the same reinforcement that you were seeing within RISAFloor, but it's now in AutoCAD, and you can include this in any of your drawings, which is really great when you're trying to get your construction drawings out. All right, so in addition to the elevated slab design features that were added within RISAFloor, obviously we have all of those same material codes that I asked about, or that I talked about with RISA-3D. Those are also added in RISAFloor. So new cold form steel, new wood, new masonry, that's all in both of those programs. Another really nice feature that we added is the ability to pin the top of a column. And this is really helpful when you're using continuous beams over columns. So you don't want to have a moment transfer because that beam is just running continuously over the top. So you can now pin that column as well. So now we're going to move on to RISAFoundation to show you what's new with RISAFoundation. We added the ability to have wall strip footings within RISAFoundation, and also to be able to add stem walls in for slabs. So this is a really nice feature for when you're bringing, this is really great when you're bringing walls over from RISA-3D or RISAFloor. Now you can do the strip footing, you know, underneath them. So again, I'm going to go back into our RISAFloor. I'm actually going to close down RISAFloor and open up RISAFoundation. We don't need to save our model there. And let's see if it'll let me, oh, sorry, I tried to open both programs at the same time and it's going to get mad at me. So I'm going to go ahead and shut down RISAFloor. It doesn't like when I do that, when I try to open two programs at the same time. So we're going to go ahead and open up RISAFloor here, our foundation, I apologize, RISAFoundation, and we're going to look at those stem walls. So I'm going to create kind of just a model that has a bunch of different types of foundations so that I can show you all of the new features within RISAFoundation. So I'm going to go ahead and create a slab first, just so I can add some of those wall strips on top of the slab. We'll create an 18-inch slab. And I'm just going to make it, you know, at the bottom portion of our structure here. We'll make it about 30 feet wide, and maybe, I don't know, about, you know, 15 feet wide. So once you have your slab in here, as I mentioned in the slide, you have the ability to add in a wall on top of it. So I'm going to go ahead and add in, sorry about that. I'm going to go ahead and add in my wall. So you can draw in a stem wall on top of this. So I'm going to say this is let's say this is a 24-inch tall stem wall on here. I can go ahead and add it in. Now, it doesn't have to be rectilinear. So if you have a wall that runs diagonal, that's fine. You can do them, you know, in any direction that you want. If I look at this in an isometric view, you'll be able to see those walls sitting on top of those footings. And if I just go ahead and take a look at it in a 3D rendered view, you can see they're sitting right on top as well. So I'm going to go back to my plan view. As I mentioned, the other thing that we have the ability to do now is to be able to add a stem wall. I'm sorry, to be able to, I'm sorry, excuse me. I apologize. We have the ability to add in a strip footing underneath a wall. So we have two different options for this. If you're just doing like a gravity type wall, not a shear wall, then you can do this strip footing for gravity only. Or you have the ability to add any lateral loads that you want into it as well. So for this model, we're going to do just a gravity only wall, assuming it's under some type of bearing wall. You're going to be able to define the wall here. So I really like the interface that they're using for this. It's very similar to our retaining wall feature, but it really lets you know where you're adding the different options. So the wall thickness, I'm going to say this is a 24-inch thick wall. We'll make the length of the heel about 5 feet and the toe length about 4 feet. And we'll make the wall height about 5 feet as well. The soil height will be 2 feet, so I have 3 foot of the wall sticking out of the soil, and the footing thickness at 18 inches is adequate. And we'll keep this soil property here as well. We also want to modify the rebar. We give you the ability to modify the rebar in the wall and the footing. So that's what these two different sections are. The section at the top is how to modify the wall rebar, and the section on the side over here is how to modify the footing rebar. Now we give you a lot of different control over the design of this wall or this footing. So you have the ability to do a single layer of reinforcement in that wall, or to choose it at each face. We're going to do it at each face for our model here. You have the ability to, whether you're looking at the horizontal or the vertical bars, you can define both. So we're going to define the vertical bars here. Obviously, you can define the cover. We give you the ability to define the horizontal and vertical bar spacing. You know, what is the spacing? We will optimize the spacing for you. Or like I said before, if you want to make it, you know what, it's going to be at 18, you can go ahead and change that in here as well. For our case here, we're going to have it optimized. Same thing for this footing section. So you have the ability to say, you know, whether you want it at each face or if it's a single layer. You know, whether you want it to be, you know, 18-inch spacing, or you want us to optimize it, what the cover is. This bar increment here, when you're having us optimize the spacing, and you'll notice this bar increment is in both the footing and the wall spacing, and in much of our concrete design. when you're optimizing spacing, you don't want to have it at every 18.5 inches, right? You're going to want it at a whole number. And some people only want it at even numbers. I only want it every 3 inches or 6 inches or 1 inch or whatever it is. So in this case, I'm saying I want it every 1 inch. So that means that in order for me to go for a minimum 4-inch bar diameter spacing, then I'm going to bump it up the next. In order for me to bump it up or the program to bump it up, it's going to have to be at 5. We're not allowed to go to 4.4. And if I had changed this to let's say 3 inches, I would only be able to go from a 4 to a 7-inch spacing. So it just gives you a little bit of control over the spacing of your rebar. So I'm going to go ahead and click OK. Now you can create as many different design rules as you want. So in this dialog, I created my own, but I'm just going to cancel out of here real quick. If I go into my wall footing definitions, you'll see that footing definition I created. If you have 4 or 5 different walls with 4 or 5 different reinforcement or different parameters, you can just go ahead and create as many as you want. So you can create different ones that you want. So you're not forced to do just one type of wall. So for our model here, I'm going to say this is our wall footing. I'm going to go ahead and add that wall footing over here on this side. Actually, we'll add it on the back side here. And if I go ahead and look at this in an isometric view, you can see that that footing is there as well. The other thing that we added within RISAFoundation, and I'll just go ahead and show you this, is we added the ability to add circular pedestals to rectangular square footings. So we've always been able to do pedestals, but we did rectangular pedestals on rectangular footings. Now you can actually do a circular pedestal. So when you define your footing here and you go to your pedestal, you have the option of doing either a circular or a rectangular pedestal. So we're just going to create a footing here and add that in. Now, creating a footing is very easy. You're just telling basically the geometry, how big do you want this footing? Anywhere from 2 to 10 feet. What do you want the thickness? Anywhere from 12 to 24 inches. What are the soil properties, for this, around this footing? So I'm going to go ahead and add in a spread footing here. I'm going to say this is my footing 1. Now, I'm just going to add in 1 here at the corner just so we get a good idea. You can add as many. We'll add 1 over here too. You can add as many as you want. Now, adding in foundation elements, I'm just doing it from a scratch model, but you certainly have the ability to bring it over from RISA-3D and RISAFloor, and that's going to be the easiest bet when you're doing a full model, because once you come in here, all your loads are in here and everything. All you got to do is just draw those footings around the column or wall locations that you already have. In our case, I didn't do that, so I do have to actually define some loading here. So I'm going to go ahead and I'm going to define both some line loads and some point loads. So I'm going to put some line loads on our model here. I'm just going to do about a 500 pounds per square foot load here on our walls. So I'm going to click apply. I'm just going to click from point to point. Now, the nice thing about RISAFoundation is even though I'm looking at this in a plan view, it's always going to apply those loads to the top of the wall. So I'm going to go ahead and take a look at the isometric view so you can see that, and you'll be able to see those loads at the top of the wall. So it just makes it nice that it doesn't require us to get into a 3D view to add any of our loads. And then for these footings here, I'm going to go ahead and add in maybe we'll add in like a 3-kip load. And I'm just going to go ahead and add that at these 2 points. So once you've defined all of your locations, and again, it's going to apply that at the top of the footing, then you're ready to run your analysis. So just like in RISA-3D and RISAFloor, you have a load combination generator. You absolutely have that in RISAFoundation as well. If you've brought this model over from RISA-3D or RISAFloor, all of your loads are already going to be split into load categories, dead load, live load, and you don't really have to worry about that. So the one thing about RISAFoundation is you do have to have at least 1 service level and 1 strength level load combination. That's because we use the service level load combination, to do the stability check, especially for our footings and things. And the strength level is to actually do the design of the concrete. So let's go ahead and solve this model and take a look at some of the results. So if I go ahead and look at, let's say, this spread footing here, I get a detail report just like I would for any member within our program, within RISAFloor or RISA-3D, and it gives you all the detailed information that you could need on this. So you get your elevation view, your details of your reinforcement, and then if you scroll down here at the bottom, you're also going to get a bearing diagram here. Now, The soil bearing, I only have one here because I only had one service level load combination. But if you're running, let's say 25 different service level load combinations, you're going to get the bearing stress contour for all 25 of those configurations. And then of course, all of your design, as far as your, footing flexure design, the shear check on it, pedestal design, bearing, and then of course your overturning and sliding checks at the bottom. For our wall design, that stem wall that we talked about, or sorry, the strip wall, strip footing, you actually get a detail report as well. And it's just as detailed, which is really nice. So if I look up here, I can see all of the reinforcement design. And then down here, I can see the loading diagram. And then down here, I get to see the results. And one thing I love about RISA programs is if we see a problem with the design, we will outline it to you in red. Although, you may not think that's, when you see the red, your first reaction isn't, yay, RISA. It's typically, oh, man. But we tell you exactly what the problem is. So we're looking over here. Here's the wall design and the footing design. For the wall design, it's saying the area steel provided for the horizontal direction doesn't meet the code minimum. So we either have to decrease the spacing or increase the bar size. And that's for the horizontal bars on the wall. For the footing design, it's telling us that the longitudinal rebar spacing doesn't meet the temperature and shrinkage minimum. So we can either change the spacing or we can change the size of the bar too, because that's going to decrease the spacing. So let's go ahead and make those changes so we can get this wall to work. So it's real easy to go ahead and make changes. You just go back into your wall footing definition. I'm going to do this. This was wall footing 3 that we're looking at. You move this back over. So we're going to go back over to the rebar. Now remember, the horizontal rebar size was what was the problem. So I can either increase, maybe I do a little bit of both. I can increase the bar size. Let's increase it to maybe a number 6. And let's decrease this to maybe 12-inch spacing and see if that works. And then it also said the longitudinal bar size, the spacing was the problem. So let's go ahead and change this to be 12-inch spacing. And then let's go ahead and rerun it and take a look at our results again. So now let's look at the detail report for that strip footing and see if we fixed that problem. And if we scroll down here, we can see we did. So decreasing the spacing and increasing the size of the bar for the wall detail or the wall reinforcement work, and same thing for the footing. So you'll be able to take a look at, any of the overturning check, the sliding, the soil bearing check, the footing design, and then of course up here at the top, it gives you kind of a summary of what your rebar is. Which is a nice feature. So those are some of the new features within RISAFoundation. We also added the ability that I didn't show you to change the slab local axes. This has been a request from some of our users. I would highly encourage you guys with new features. If you have something you want to see in RISA-3D, RISAFloor, any of our RISA software, please email us. You can email info@risa.com or support@risa.com. We base new features on the number of requests we get from users. So if you can send us some, feature that you want in and you think it's a popular feature, if other people ask for it too, that's what's going to be in the next release. So, it's all based on feedback from you guys. So as always, we're always willing to answer any questions. Debbie will stay online for the next 5 minutes to be able to answer any questions. Once the webinar is closed, we post all of the questions and answers at risa.com. Just again, where you signed up for the webinar, it will be posted. And feel free to contact us anytime, info@risa.com. Thanks so much, everybody.